Okay, what's going on, dudes? Algebra 1, second video for your second assignment. I remember last time we talked about adding and subtracting these polynomials, and they had some names. Now we're going to talk about multiplying them, and there's two multiplications that we're going to focus on. We're going to focus on one called the distributive property. It's when you have a monomial, one term, multiplied by a polynomial. And I say polynomial, but it can be two terms, three terms. It could be one term. It could be four terms. We're going to call it a polynomial because that's the generalization for it. Basically, you're taking one thing and you're going to multiply it to multiple things. And when you do that, you're going to do the distributive property, which we learned earlier this year. So like this first one, let's run through it real quick. I want to multiply this -6 inside of this parentheses. So I need to make sure that I take it to every single term in here. So when I do this, I do -6 times 4x squared. And here's how you do this. You just multiply the numbers. -6 times -4 is -24. And that x squared is not multiplying by any other variables, right? This -6, doesn't have a variable with it, right? So the x squared just tags along. So it becomes -24x squared. And then I do the same thing with the middle term. I do -6 times 3x. Again, -6 times 3 is -18. And that x is not getting multiplied by another variable, so he's chilling, he's staying in x. And then at the end of the problem, it's -6 times -4, which is a +24. So that's a pretty simple example, but that's like how your assignment starts, just to get you refreshed on how to distribute. And then we get into the ones that are, I'm not just distributing a number, I'm distributing a number and a variable. So it brings in the section we just learned. When you multiply variables together, you add their powers. So real quick, you treat the number as normal though. So 3 times 2 is 6. Now I'm doing x times x. Well, the power on this x is 1. The power on this x is 1. When I multiply x times x, I add their powers. 1 plus 1 is 2, so that becomes an x squared. Okay? And then I go back and I take that 3x and I distribute it to the 7. So 7 times 3 is 21. And this time the x isn't multiplying by another variable, so he stays the exact same. So he stays an x, so it becomes 21x. So two more of the distributive property. This time I'm distributing 4x squared. So 4x squared times 3x squared. Well, 4 times 3 is 12. X squared times x squared. I'm multiplying this guy and this guy together. That means I need to add their powers. 2 plus 2 is 4, so this becomes an x to the 4th. And then I'm going to multiply 4x squared times 2x. Okay, gotta multiply by every single term. So 4x squared times 2x, 4 times 2 is a +8. And then an x squared times an x, which has a power of 1, I have to add those powers. 2 plus 1 gets me an x cubed. And then I go back and I do 4x squared times -6. That's a -24. This x squared isn't multiplying by another x, is he? There's no x there, so he stays x squared. So we're keeping what we learned last week. When we multiply variables, we have to add their powers together. So one more to finish it up here. I have -3x getting multiplied by this polynomial. So -3x times -6x squared. -3 into -6 make me 18. But again, when I multiply these, I have to add their powers. 1 plus 2 gets me x cubed. And then I do -3x times 5x. Well, -3 times 5 is -15. And here we go, making sure we got it. An x and an x, when I multiply them, make an x squared. Because their powers of 1 add to get a 2. And then -3x times -2 is a +6x. X doesn't change because he's not multiplying by another variable, right? He's just going to be multiplied by -2. That don't change his power. His power only changes when he multiplies by another variable. So that is our answer, and that's how you do the distributive property. Okay, and you're going to do that when it's a monomial, one single term in front of parentheses. You're going to distribute it into each term, remembering to add exponents when you multiply. And then we have the FOIL method. Okay, you're going to use the FOIL method when it's a binomial times a binomial. So in each of these problems, each parenthesis has two terms, making it a binomial. So we do the FOIL method, and here's what the FOIL method stands for. The F is first. The O is outside. The I is inside. The L is last. And this is going to tell you how to multiply these things together. So when it says first, it means, and how about we do this color? That's going to be red. This can be yellow. This can be green. This can be black. Okay. So the first term, when it says first, it means the first term in both parentheses. So the first term is 2x in the first parenthesis, and the first term in the second parenthesis is 4x. So I multiply those together. 2x times 4x is 8x squared, right? Because we just talked about that, and x times an x gets us an x squared because we had the powers. And then outside, the outside terms. If you're looking at this and there's 4 of them, the two that are on the outside would be the 2x and the negative 4. Right? They're outside. The ones at the beginning, ones at the end, that puts them on the outside of the problem. So 2x times negative 4 is negative 8x. And then inside, well, if those two that I just talked about are the outside, then the two that are right in the middle are these guys. 3 times 4x, which is a positive 12x. And then last, well, that means the last term in each parenthesis. So the 3 times the negative 4, because they're both the last term in their parenthesis. And that makes a negative 12. And then to finish the problem up, you are going to combine like terms. Okay, so 8x squared, can he combine with any of these? No, he can't, right? If he was to combine with something, they'd have to have an x squared as well. So he's part of the answer. I can combine these two right here, though, right? Negative 8x plus 12x, those are like terms. They both have an x, and they both have a power of 1, so I combine them. Negative 8 plus 12 is a positive 4x. And then this negative 12 doesn't have a buddy. There are no other just plain simple constant numbers in our problem. So he just tags along at the end and we get our answer. First, outside, inside, last. So let's do another one here. First, 3x times 2x, that is 6x squared. Outside, remember it's this term and this term, always, which in this case 3x times 4 is a positive 12x. Inside is always the two right in the middle. Negative 5 times 2x is negative 10x. And then last is always the last two terms, which in this case is negative 5 and 4. The last term in each parenthesis, which gets me a negative 20. And then we simplify our answer. 6x squared is in our answer because he doesn't have another buddy. There are no more x squareds in my answer. I can combine these two because they are like terms. 12x minus 10x is positive 2x. And then negative 20, just chilling at the end, he does not have a buddy. And notice how these answers kind of put themselves in standard form as you do them, which is nice. The highest power, the next highest power, and your constants always last. Okay, another one. First, again, which is the first thing in both parentheses. 3x times 2x is 6x squared. Outside is this term and this term. The two outside when you look at them. All right, always those two terms, so that's negative 12x. Inside is always the two right in the middle, so 8 times 2x, which is positive 16x. and then your last, which is the last term in each parenthesis. So 8 times -4, which is -32. And then in the end, you do combine your like terms. So I have 6x squared. He doesn't have a buddy. No other x squareds in this problem, right? I can combine these two because they're both x's. So -12x plus 16x is a positive 4x. And this -32, you tag him on at the end. He doesn't have anybody to combine with. So this is the FOIL method. First, outside, inside, last. Now, if you notice, I'm still distributing, which is the interesting thing. So if you're confused maybe about the FOIL method, you can think of it this way. I'm going to distribute this 3x to both terms. Isn't that what I did right here? Nah. Nah. Right? Just called it first and outside. And then I'm going to go back and I'm going to distribute this 8 to both terms. Isn't that what I did right here? Just called it inside and last. It's still technically distributing, but when you do a binomial times a binomial, they have a fancy name for it. It's called the FOIL method. Okay, first, outside, inside, last. But if you think about it as just distributing, it works the same way. You distribute the first term to both terms in the other parenthesis. 3x times 2x, 3x times -4. And then you go back and you distribute the 8, the second term here, to the 2x and the -4 in the other parenthesis as well. And you'll get the same answer. Okay, so if you want to look at it that way, that's fine. It'll get you the same answer in the end. But we just call it the FOIL method. And then the last one here, the one that a lot of you will probably try to, if you've never seen it, which you haven't, you would try to distribute this too, and kind of like we did last week. Remember, last week we had problems like this? And I said, hey, take that 2 to both exponents in there. So it would be 4 squared and x to the, remember you multiplied the exponents here. So x to the 4th. In the end, 4 squared is 16. We'd get 16x to the 4th. Check, check. That's good. That works. Right? I'm allowed to distribute that 2 into the other exponents. Here, I'm not allowed to. Okay? I told you last week, if you watch the video, you can only distribute an exponent if it's into a monomial. This is a binomial, right? There's 2 terms here. I'm not allowed to distribute this 2 in. So, nah. Right? Can't do that. But what I can do, when something is squared, that means there's 2 of them. So I'm going to rewrite this as 2x plus 4, but I'm going to write 2 of them instead of making it squared. That means the same thing. Okay, when something is squared, there's 2 of them. And now I can multiply them together with the FOIL method that we just learned, right? Or let's do this one distributed method. Why not? Let's distribute this 2x. So 2x times 2x is 4x squared. 2x times 4 is positive 8x. And then I go back and I distribute this 4. 4 times 2x is 8x. And then 4 times 4 is positive 16. And then in the end, 4x squared, he doesn't have a buddy. I can combine those two. They become 8x plus 8x is a positive 16x. And then the plus 16 just chilling at the end. And that is our FOIL method and our distributive method. Okay, so this is your second assignment. Okay, again, if you guys have questions, message me on Remind, email me, text me, whatever. Look at my video, look at other videos. It's brand new material. I don't expect it to be easy, but I do want you to have seen it. Because in geometry, you are going to do some of this stuff, and I don't want you to be behind when you get there. Okay, so again, if you have questions, contact me. Watch these videos. Really, truly try to pay attention. Last week, we're here, end of the year. Doesn't feel like it normally does, because we haven't been in school in a long time. I miss you guys. Hope you guys get this done. Have a good break, and hope to see you as soon as possible.